Question 8 is a fairly manageable question all about quadratics. So it starts off in question A, asking us to write down the value of h and k. So remember, whenever you see write down, it means it should be fairly straightforward. And the way to do this is looking at the vertex. And straight away, we should be able to see that from the vertex, h goes into here, and k goes into here, because this is vertex form. So therefore, we can write straight away that h equals 1, not negative 1, because there is always a negative sign here, that's the convention. So therefore, h is just 1, because we've taken that straight from the coordinates, and then k is going to be negative 9. In part B, then, we're asked to find the value of c here. So we're going to find the value of c when our input is 0. So in essence, we're being asked to find f of 0, which is going to be 0 minus h, which we said is 1, all squared minus 9. So remember that I've got negative 1 and I square it, that's going to give me positive 1. So positive 1 minus 9 is going to give me negative 8, which is my answer for C. We're told then in part C that there's a second function, g of x, such that negative x minus 3 squared plus 1 is g of x. And we're told that the graph of g is obtained by a reflection of the graph of f in the x-axis, followed by a translation of p, q, and we're asked to find the values of p and q. So first of all, we can look at the reflection. So it's going to be doing something like this. So we can see that if we reflect it in the x-axis, the vertex here is going to be 1, 9. Given the expression we have here, we can see that the vertex of g of x will be at 3, 1. So the vertex of g of x will be somewhere here at 3, 1. So we are told that from the vertex of f of x, the graph is reflected in the x-axis. So that takes us up to here at the point 1, 9. And then there is a translation from here, the vertex here, to the vertex of g here. So we can see that there has been a horizontal translation 2 units, which means that p is going to be 2. And from 9 down to 1, there is a vertical translation downwards of 8 units. So the translation will be to negative 8. For part D, we are asked to find the x-coordinates of the points of intersection of f and g. So for this, we are going to set the two functions equal to one another. So I will have x minus 1 squared minus 9 is equal to negative x minus 3 squared plus 1. I can then simplify, so if I end up with x minus 1 squared plus x minus 3 squared, and then I bring over the 1, so that's minus 10 equals 0. If I then expand that, so here I will have in the first bracket x squared minus 2x plus 1, and the second bracket will give me plus x squared minus 6x plus 9, and then I've still got this negative 10 here equals 0. So I can simplify then that, which will give me 2x squared minus 8x, which is equal to 0, and I can factor out the 2x, which leaves me with x minus 4. So the only way this can equal 0 is if this equals 0, in which case x equals 0, or if this equals 0, in which case x equals 4. So the x coordinates are x equals 0 and x equals 4.